In the last lesson, I explained that you can use a bit mask in order to test whether or not certain bits are turned on. In this lesson, I'm going to show you how to use a bit mask to actually change the data. Now, we could do this by taking letters and changing them. For example, we could take a lowercase letter and make it into a capital letter. However, for this lesson, we're going to be doing something slightly different. We will be taking actual numbers and turning them into text. So let's imagine this byte, which is, of course, the number 2. Now, we know from our earlier lessons that the character 2 would have the third and fourth bit set to 1. In order to change a number 0 through 9 to a character, we therefore need to set the third and fourth bits to a 1. Now, there are a variety of ways to do this, but I want to show you how to do this using the bitwise OR operation. So first of all, we need to create our bit mask. This is the number we're going to change, and because we want to change the third and the fourth bits, our bit mask is going to look like this, where we have set the bits that we want to change to 1 while leaving everything that we don't want to change as 0. Now we can simply apply the OR operation like this. And if you remember, the way OR works is that 0 or 0 is 0, but anything else is 1. So you'll see that the result here is that we have changed the number 2 to the character 2 simply by applying OR to the number. Now, what happens if we start with the character 2 and we apply the same bit mask? The answer is we'll get the same result. When you're using OR, you can only turn a bit that was off on. If a bit was already on, it will stay on. And you cannot use OR in order to turn a bit off. So when you're using a bit mask with OR, every bit that you have set to 1 in your bit mask will be set to 1 in your final result, along with any other bits that were set to 1 in your original. So by using this particular bit mask on numbers, if it is a number, we'll change it to a character, and if it is already a character, it will stay a character. Okay, now let's go ahead and write out a simple program to demonstrate how to do this. So we're going to need a number. Now this is going to be 1 byte in size. So we're going to call our number 2. Keep in mind that char as a data type means that what we are doing is we are using a single byte. It doesn't necessarily mean that it has to be an ASCII character. It just means that it has to be one byte in size, and you can certainly use character to store numbers. And you can, of course, store values from 0 to 255 because that's how large a byte is. So here we are creating a variable called myNumber, and we're setting it to the value of 2. That means that this byte in memory is going to look exactly like this. Now, let's go ahead and change it from the number 2 to the character 2. The way that we can do that is like this. We can say 2 or with our bit mask, which is going to be this, but of course I'm going to remove the space. And now the only thing that I have left to explain is how do you write OR in C, and the answer is with a single pipe bar, not with 2 pipe bars like you do in a conditional statement, but a single pipe bar is a bitwise or Boolean OR operation. Now, after we've executed this, my number is going to look like this, because when you apply OR using this bit mask to this, you will get this, just like I showed you before. So let's go ahead and take a look at this. So right now, my number is already set to the char data type, and it should be actual text. So let's find out. We'll do a printf statement. %C indicates that we want a character. And now, if we run this program, you will see that it printed the character 2, which proves that we have correctly set the third and fourth bits to 1. Now if we want to, we don't even need to change it here. We can change it right in the printf statement. In fact, we can do so in a way that doesn't actually change the value. Now what I'm doing is I'm saying that for my character, I want printf to use this. Now of course I need to remove the space, and that's fine. This should execute, as you'll see. And again, it printed the character 2 because it's changed the number 2 to a character by setting the third and fourth bits. And lastly, what we can do is we can change this from binary to hexadecimal. This is going to be 3, this is going to be 0, and there you go. So this shows you how you can use the OR operator to change a number, it would have to be 0 through 9, to an actual character. Now if we go ahead and set this to 5, then what's going to happen is that my number is going to look like this. And we apply OR using this bit mask, and we will get 0 or 0, 0, anything else is 1. And this of course is the text character 5. Now what if we want to alternate a bit, that is to take a bit that is set to 1 and set it to 0, or vice versa? Well, for that we would use a different kind of bitwise operation called XOR, which means exclusive OR. So now you know that there are two bitwise OR operations. There's OR, which we've already looked at, which is called inclusive OR, which means either, including both. And then there is XOR, which is exclusive OR, which means either but not both. So XOR and OR are very similar. The only difference is this: 1 OR 1 is 1, but 1 XOR 1 is 0. Now why is that? Because this does not meet the requirement of either but not both, because both are set to 1. Alright, so let's just briefly review the three main bitwise operations we've looked at. Let's start with AND. So of course 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and the only way that you get a 1 with AND is 1 and 1 is 1. Now if we look at OR, 0 or 0 is 0, and then anything else is 1. 1 or 0 is 1, 0 or 1 is 1, and of course 1 or 1 is 1. Now if we're looking at XOR, which is exclusive OR, which is either but not both, it's going to be exactly the same as this, except 1 XOR 1 is 0 because it does not meet the requirement of either but not both. Now there is a reason for the difference that I just showed you between XOR and OR. Let's take a look at what happens if we try to change a capital A using XOR and a bit mask on the third bit. So remember, with XOR, the only difference with OR is that 1 XOR 1 is 0. So 0 XOR 0 is 0, then we have 1, 1, 0, and this is the final result. So notice here that we have changed the capital A to a lowercase a. We could have done that with OR. But now watch what happens if we take the lowercase a and we apply the same bit mask that we just applied to the capital A, and again we use XOR. Now 0 XOR 0 is 0, 1 XOR 0 is 1, 1 XOR 1 is 0, that's the difference between OR and XOR, the only difference, and then the final result we get is this, and notice that we have now changed the lowercase a back to a capital A. In other words, each time we apply the bit mask, we are alternating the bits in the bit mask. We could repeat this process as many times as we want. Each time we'll flip the bit. So if we did it again, we would change the uppercase A to a lowercase a, and if we did it again, we change the lowercase a to an uppercase a, and so on. So using XOR is a way to toggle a bit, changing it from 1 to 0 or 0 to 1 without affecting anything else. Now, how do you write XOR in C? The answer is this character. This just means XOR. So the three main bitwise operators that we've looked at work like this. This is AND, this is OR, and this is XOR. Keep in mind that when you are looking at source code, you will see bitwise operators be used. This is true not just for C, but for any programming language. Being able to read that source code critically depends on your ability to understand why someone would use AND versus OR versus XOR. So remember this. By using bitwise operators, you can test, set, and unset, as well as toggle any bit in any data you wish. Now, this lesson wouldn't be complete without an example program, so let me go ahead and write one real quick. So what we're going to do is use the concept that we just looked at to toggle a lowercase letter to an uppercase letter and vice versa. So we'll create a character, set it to a lowercase a, and we'll have a printf statement that will print the character, say with a new line. Now we'll change it by the XOR operator with our bit mask. That is going to be the third bit. Of course, I don't need that space. And now I'll run the printf statement again. We'll change it again and run the printf statement again, and you should see the effect. And there you go. Lowercase, uppercase, and back to lowercase again. If I wanted to have this in hexadecimal, I would just change this to 20 hexadecimal. Same exact program. And there you go. Now, just to recap the way that this works, if we want to take this and break it down, it would work like this. Well, my character is a lowercase a, so that would be written like so. We are applying the XOR operation. This, of course, becomes this. So 0 XOR 0 is 0, 1 XOR 1 is 0, and we are left with a capital A. Now, as always, if any of this is unclear, feel free to ask questions, and that concludes this lesson.